Every day we see things in our life, but we never really stop and think about how they work. Lava lamps, for example. Today I will be explaining the lava lamp lab and how it works. As you can see in the picture, we have oil and we have water, but they are mixed together. This is because of their densities. Oil is less dense or less compact than water is, so it sits on top. This is also known as a suspension. A suspension is when two things don't mix together. A suspension is also a heterogeneous mixture. This is because it can be separated easily. If you wanted to, you could easily get the oil and water by themselves in separate cups. So this is not a homogeneous mixture because homogeneous mixtures can be separated, but it is very, very difficult. An example of this would be a well-mixed glass of Kool-Aid because it is constant throughout the glass. This can also be classified as a physical change because it's affecting the way it looks, not its chemical structure. It can easily go back to the way it started. Mixtures are just one part of how matter works, but there's also something called pure substances. And just like mixtures, it's broken down into two parts: molecules, which are atoms bonded together, and elements. Elements are what you will find on the periodic table of elements, and they are found in their purest form, but molecules are elements that are together. They can be found in compounds, but not all of them. So right here we see water, which is H2O, and the Alka-Seltzer tablet, which is C16, H17, Na, oxygen 14. So to show water, we have one oxygen and two hydrogens, and that shows 8 valence electrons in the outermost shell. So we now know a little bit of background on the lab, but what will happen when we do the experiment? Well, we have our solvents, oil and water. These are the things that are going to dissolve our solute, which is our Alka-Seltzer tablet. This will create a solution, which will be our experiment, the lava lamp. The oil and water are liquid, so they have an indefinite shape but a definite volume. The tablet is a solid, so it has a definite shape and a definite volume. This will have a very quick solubility because the tablet dissolves very quickly. When we drop the tablet in, we'll see a chemical reaction. This is a chemical reaction because we will not be able to bring it back to its original form. Now let's see this experiment go. So when we drop the tablet in, it reacts with the water to make very tiny bubbles of carbon dioxide, which practically are gas bubbles. These bubbles are gases, so they have indefinite shapes and indefinite volume. These bubbles, which are right here, attach themselves to colored water and cause them to float to the top of the oil. When the bubbles pop, the colored water sinks right back down to where it came from, and this process will continue until the tablet works out. I hope you learned a little bit more about how a lava lamp works. See you next time!